All right, guys, what's up? Data here tonight, and tonight we are going to build a network traffic monitoring device, and this is really just going to be a Raspberry Pi, and then a Netgear switch, which is able to do what's called port mirroring. So the idea here is we're going to be able to build a device that will be able to look at all the traffic or all the data packets in our network. And this is useful for a lot of different things, troubleshooting different devices, verifying bandwidth from your ISP, troubleshooting various network issues. But it's really useful to be able to see, what traffic is going on your network. It can also be used for security. You can deploy different intrusion detection software on devices like this, or even just capture traffic for analysis later. So, lots of different things we can do. But the problem is you need to actually have this at a point in your network where all of the traffic will be visible, meaning basically right before the router. Otherwise, you're not going to be able to capture all of the traffic in your network. So anyway, that's what we're going to do today. Is we're going to put the switch right before our router, so that all of the outgoing packets and incoming packets will be sniffed, and we can get a full picture of what's going on in our network. So anyway, guys, what we got today is this is Raspberry Pi 4. This came as a set. So this is a micro HDMI to HDMI. So, most people have HDMI cable laying around, so it's really the only new thing you're going to need. This is a adapter and then a USB-C outlet, which goes to power the Pi. This is a basically SATA to USB-C, and then I have another adapter that changes this from USB-C to USB 3.0. So that's going to be what we're going to use to as the memory for the Pi, or memory and storage, I guess in this case. No, sorry, this is going to be storage for the Pi. It has 8 gigs of RAM in there already. And then finally, this is the switch, which is looks like a GS35E. But anyway, nothing super particularly special about this except for the fact that it supposedly has port mirroring. So that's the really important thing here. I never set one up before, so we'll figure out how to do that tonight. But without further ado, guys, we're going to go ahead and hop in and get the Pi set up. Alrighty, guys, so the first thing we need to do here is we need to image the disk, or image the drive that we're going to be using to boot with. So what you can do, or I think the easiest way to do this, is to open up browser and then go to Raspberry Pi imager, and then boom. There you go. So you can install Raspberry Pi OS using the Raspberry Pi imager. You can download for Windows, Mac, whatever your system is. So do that. It's fairly easy to install, nothing too crazy. And then you can, once you have it installed, open it up. And then you can choose your device. So in this case, we're going to do Raspberry Pi 4, as the Raspberry Pi 5 is not even out yet. And then you can choose your OS. I've used a bunch of different OSs on Raspberry Pis. I find, unless you have a really particular application, typically the Raspberry Pi OS works the best, and it's optimized for use with the Raspberry Pi. So this always seems to work the best for me. Otherwise I would almost always use Ubuntu server. But anyway, so in our case, we're going to use this guy. And then the storage device. Oh, you know what? I've already imaged it, so amazing. Yeah, so problem there was I had, and I know this is crazy, but I had the USB-C flipped. So I have an adapter from the USB-C to the USB 3.0, and believe it or not, it actually does matter which way you connect it. There is a right and a wrong way. One way the computer will recognize it, one way it will not. It's probably because I'm using a shitty adapter. But anyway, that was the issue. So now we can see it's recognized as a disk, and we can select that, and we can go to next. One thing I will say here is I think it's easiest if you use custom settings. So for me, I always like to set a recognizable host name, username, password, go ahead and configure the Wi-Fi, time zone, etc. And then services. So I always SSH into Raspberry Pi as soon as possible. So as soon as we finish setting it up initially and enable SSH, then I'm going to go ahead and put it where it needs to go, and then we're going to SSH into it from there. So, as far as I'm concerned, this is the easiest way to go. So, up to you, but I always like to configure these options. And then, if you want to have it play us out when it's finished, you can do that as well. So anyway, there we go. And then we're going to apply custom settings, yes. And then do you want to go through with it and image it and erase everything? And in my case, no, I've already done it, so we're going to go ahead and not do that. But if you needed to, go ahead and image it, and then you will have a disk that is ready for use with your Pi. So now the next step is basically just taking your drive now and plugging into your Pi, turning it on, and then you should be able to directly interact with the Pi. All right, guys, so change of plans. I'm actually just going to leave it plugged in next to my computer for now because it's going to be easier to work with, and I need to install a few more pieces of software before we go install it next to the router. So what we're going to do is we're just going to go ahead and open up a terminal, and then we're going to SSH into your username at whatever your IP address is. And one thing to note here is you may want to give this a static IP address, or rather make an address reservation with you in your router settings. Even if you're using like a router from your ISP, most of the time they'll still give you the ability to go in and reserve an address for your particular device. Otherwise, if you turn it back off and turn it back on, it may be assigned a different IP address, and you won't be able to access it, or you'll have to figure out what the IP address is then to SSH in. So anyway, just one one tip that might make your life easier in this respect. So and it will change from router to router, but that's just one thing to note. And I can't tell you exactly the easiest way would be to Google your particular router and figure out whether it's possible, and then if so, how to actually go about doing that. So anyway, we're going to go ahead and SSH in. Yes, we want to establish the fingerprint, and then we're going to type in the password we set earlier. And there we go. So now we're into Wireshark, or now we're into the Raspberry Pi. So first thing that we want to do is we're going to install Wireshark, and then we're going to install something called XRDP, so that we can remote desktop in or remote into the Raspberry Pi and also access the GUI. So that's going to allow us to interact with Wireshark, at least the GUI there, so we can actually see what's going on. So first of all, we'll go ahead and get Wireshark installed. I guess I have to do capital Y. Capital Y. There we go. Okay, so should non-super users be able to capture packets? In this case, since the whole point of this device is that we're trying to capture packets on Wireshark, I'm going to go ahead and say yes. But if you're using this in a more production style environment, you probably would want to say no. But in our case, we're going to say yes. Go ahead and let that load. All right, excellent. And then the last thing that you can do is sudo, I can't type today, sudo user mod -ag, and then this is going to be Wireshark, and then we're going to add that. We're going to add ourselves. So in this case, SDK is the main user. We're going to add that to the Wireshark group. And this way, we should just be able to launch Wireshark this way. However, it's going to fail since we don't have the ability to use a GUI at this point. So, all right, now, first, or I guess step one, we've got Wireshark installed. Now what we need to do is we need to give ourselves a way to access a GUI. So there are a couple different ways to do this, but the easiest is probably just going to be to remote into the machine. You can also do, you can forward the GUI to your remote machine, but we're not going to do that right now in this video. But if you'd like that, just let me know in the comments, and I'll make a video up for this. But for my needs, this is going to be sufficient. But anyway, so now at this point, what we're going to do is we are going to install XRDP so we can remote desktop or remote into the machine with a GUI. All right, so the first thing we're going to do, and I forgot to do this earlier, is we're going to run sudo apt update, and this will just update all of our dependencies, and then we will run sudo apt upgrade, and that will actually update. All right, guys, thanks for bearing with me there. Next, we need to install XRDP. So the command for that is sudo apt install XRDP. And a lot of people use VNC, or there are other options to remotely access the GUI. You could also use X2Go. I like RDP specifically because it's the most performant, and also it has the highest level of encryption. So, feel free to use whatever you'd like, but the reason why I am choosing RDP specifically is for those two reasons. All right. So now the next thing we need to do is we need to start the service. So sudo service. This is XRDP start. There we go. And let's just make sure that everything's working correctly by checking the status. Okay. All right. Now we should be able to access our machine. So what we're going to do is go to remote desktop connection. And I think that's the one that I set. Okay, so this is the IP address we have, the private IP address we have assigned to the Raspberry Pi. So in theory, if we hit connect right now, we should be able to connect to a Raspberry Pi. Okay, so let's type in our username and password, and boom, there we go. So now if I've done everything correctly, I should be able to, open up Wireshark. Excellent. Okay, so as we can see, we now have ETH0, our wireless interface as well, and then and then even we can look at Bluetooth. So we have a lot of different options here as far as traffic we can look at. Let's look at Ethernet 0. So as you can see, we are looking at all of the traffic for where it's currently plugged. So we can see everything that's on the switch in my bedroom. In this case, there's only a couple of different IP addresses. So there's 90, 79, and 69. So one is my computer, the Raspberry Pi, and I think maybe my TV, or maybe something else. I'm not 100% sure what that one is. But anyway, not a whole lot really that's going on, on this particular switch. So we need to move this to,
right before our router, so that basically all traffic moves through the switch, and then set up mirroring so that this Raspberry Pi will be able to see all the network traffic that happens in our entire home, or in at least for my case, my entire home. So that's the goal. And what we're going to do now is, now we've got everything set up, we'll take this and we'll get the switch figured out as far as the port mirroring, and then we'll set it up over next to the router. So I'll see you guys in the next part.
Alrighty guys, for this next part, we're gonna need 3 things. Well, I'm gonna need 3 things. You might need 2 things. Just depends on what kind of computer you have. So the first thing we're gonna need is we've unboxed the switch we were looking at earlier. So the Netgear GS35E switch. It's a 5-port unmanaged but customizable switch. So in this case, we're going to enable port mirroring. So the first thing we need to do is we need to actually connect to the configuration interface. So what we need to do is we need to connect an Ethernet cable to this guy, and then we need to connect it to our computer, and then configure the IP address such that we can reach, or they're on the same subnet, and we can actually reach this switch, so we can get the interface and configure it. So what we're gonna do first is I'm gonna go ahead and just plug this in port 1. Okay. Next, what I'm gonna do is I have a little adapter because I only have USB-C on my Mac. So we're gonna go ahead and plug that in, and then we'll undo this, and we're gonna plug this guy into the computer. All right, now it says that the default IP address of the switch is 192.168.0.239. So what we need to do is we need to go to network, no, not network app. Sorry, let's just go ahead and open this. So we need to go to network, and we need to go to LAN. Okay. And so we'll put it manually, and we want our IP address to be in the same subnet as the one that we're trying to connect to. So it said it was 0. So let's configure this as 0 dot, that's this 239, let's just say 201. So we should be in the same subnet, and we should be able to reach let's just turn Wi-Fi off really quick. Okay, so now if we type in 192.168.0.239, we should be able to connect to the switch. Oh, you know what? Because I haven't plugged the power in. That's why. Alrighty guys, so turns out when you plug the power in, it actually works. So another thing to note is it did take about 2 or 3 minutes for the machine to actually boot up, and then the web server that lives inside of the switch to actually start hosting the website, so that, or the interface, so that it's actually accessible. So, you know, if it doesn't come right away, don't get discouraged. You're doing the right thing. It's just not, you know, not accessible yet. So anyway, the default password in this case is password, according to the instructions. So, okay. So what we're gonna do now is we'll just go ahead and we'll configure a new password. Sorry about that, guys. Password is finally set. All right, guys, I just took a minute to go through everything really quick, and it's actually really impressive. This has a lot of functionality for the price. I think I paid like 20 or 30 bucks for this. So for a 5-port switch, that's, you know, fairly expensive, but you know, you have the ability to set VLANs. You have the ability to you can manage, you can look at your port statuses, you can, has loop detection, has multicast, has a lot of different things that a lot of people, would be interested in. So anyway, in our case, what we're most concerned about, or what we're most interested in is, well, actually first let's set a switch name. So we're gonna call this guy, this is going to be TFS, so traffic monitor, sorry, let's call it TMS, traffic monitoring switch. So there you go. Another thing I want to talk about is the DHCP. So we're gonna leave this enabled. At least I am. I'm going to go on my router and just give this an address reservation. So next time I turn this off and back on and it's connected to the larger network, not just to my laptop, it's gonna go ahead and automatically assign it an IP address so I can reach it on our local network. So you can choose to assign it statically here if you'd like. You can change this to disable. And then you can set, whatever IP address you want in your subnet, and then adjust the subnet mask and then gateway accordingly. But for me, I'm just gonna, I prefer to do it the other way because it just makes things more seamless to do it with DHCP rather than adjusting everything statically. But anyway, to what we're trying to do here. So we want to go to monitoring, and then we want to go to mirroring. And so what we want to do is we want to, I was playing with it earlier, so I guess it saved that. But whenever it looked like it was default, it was look like this. So what we want to do is, and you can do this, on whatever port you want, but the idea is we want all of these 4 ports to be mirrored onto the particular port where we're going to have our Raspberry Pi listening. So we're going to enable, and then we're going to say the destination port is here, and then we're going to listen on all of these ports. And you could probably, I guess you could do all of them, and then you would get the traffic from the Pi itself. So it's up to you whether you want the Pi's traffic included or not. I'm not really too concerned with the Pi's traffic, to be honest, so I'm just going to mirror all the other ports. Actually, you know what? I'll go ahead and include this, and then I'll just filter out the Pi in Wireshark. So we're going to go ahead and apply. Okay, source port and destination port can't be the same. Okay, some will allow you to sniff loopback traffic like that. But, all right, so anyway, there we go. So all of these ports all the traffic that goes through these ports is going to be mirrored or copied onto this port, so that our Raspberry Pi can capture it or look at it or do whatever you want to do with it. But that's the main thing here. All right, so everything should be set up correctly now. So from this point, what we're going to do is we have our Pi configured correctly, and now we have our switch configured correctly. So what we're going to do is we're going to go take these downstairs to the router, and we're going to plug the switch in basically right before the router. And then everything should be working, and we should be able to SSH into our Pi, or I guess remote into our Pi with RDP, and look at Wireshark and look at all the traffic that's going on our network. So next part, we will go ahead and install the Pi and the switch. All right, guys, so here we are downstairs at the router. And what you're looking at here is, this is a Deco X55 router / wireless access point. It's configured in this case to be a router. And this is an Aris, I forget the model, modem. But the yellow Ethernet cable is outgoing from the router to the modem. And then these other two are inputs. One of them is coming from the switch, which just has all of the stuff in the cabinet. So like, for example, the TV, there is an audio switch for some overhead speakers and a couple other small things in this cabinet, and then everything else is coming from a switch or larger switch downstairs from this cable. So basically we want to mirror these two and direct these to our Raspberry Pi. So what we're going to do is we're going to plug these into the ports that we just set to mirror, and then we're going to take an outgoing from the switch into this router. And then once we have that configured, we'll plug a Ethernet cable from the mirroring port into the Raspberry Pi. So I'll show you what that looks like in just a second. I won't be able to hold the camera and do it at the same time, so I'll configure it and then I'll show you what's going on. Wow, that's awesome. Okay, I didn't know that you could have flash and video at the same time. Okay, so I learned something new today. Anyway, so guys, this is now what we're looking at. So those two wires, or two Ethernet cables that were plugged directly into the router, are now plugged into the mirroring ports on the switch. Okay, this outgoing port or outgoing Ethernet is going directly from this switch into our router. So basically all traffic in the house is coming through these two Ethernet cables, and then it's going out through this port 3, all the way through to the router, and out the modem, and out to the broader internet. So now we have set up port 1 to do the mirroring. So now what we're going to do is we're going to connect port 1 to the Ethernet port on a Raspberry Pi, and all the traffic that goes through any of the other ports is going to be mirrored to our Raspberry Pi. So I'm going to go ahead and pause the video and I'll make that happen, and then I'll show you the final results. All right. So guys, now that's everything plugged in. I know it's a little hard to see now, but so we have our mirror, or the Ethernet cable that's mirroring, plugged into port 1, and then our two incoming Ethernet cables, and then our outgoing Ethernet cable to the router. So guys, there you have it. A little bit messy, but I'm gonna go ahead and clean everything up now that we understand what's going on. And then we'll go back upstairs and we'll SSH in, and we'll see if we can actually see all the traffic from the house.
Alrighty guys, here we are back up with the computer, and we are going to get back into the Raspberry Pi through the GUI, or through RDP rather. Just bear with me 1 minute while we reconnect. Alright. Let's get that password in there. Alright. Excellent. So I went ahead and saved Wireshark as an icon. So you can do that by going up here and then just dragging this to your desktop screen in case you would rather open it this way. I just prefer it's a little bit easier. So we're going to go ahead and open Wireshark now. And we're going to select the Ethernet interface. And it's going to start grabbing a whole bunch of traffic. So I can already tell you right now, there's way more traffic from a lot of different variety of IP addresses than we had before. But just to kind of quantify this a little bit further, what we're going to do is we're going to let this run for about 5 more seconds. And then we're going to stop it, and we're going to look at the statistics, and we're going to search for the source IP addresses within our particular subnet. So I'm going to go ahead and stop it now. And then we're going to go to statistics. We're going to go to, I believe it's endpoints. No, I don't think I want that one. Let's do, here we go, IPv4 statistics. I'm going to go to source and destination addresses. Go ahead and let that load. And then we can type IP dot source equals, and then we'll type in our subnet 192.168.68.0/24. So that's going to, if it started in our subnet and was going out, it will filter all of those out for us. All right, excellent. So let's go ahead and just look at the, please go away. All right, let's look at the source. All right, so anyway, as you can see here, all of these were the IP addresses in our subnet that were, over that 20-second span, were sending traffic. So that I can tell you is the Raspberry Pi. That's my personal desktop computer I'm on right now. These 7172, those are servers downstairs. And those are all the ones that I recognize off the top of my head. But the point is, and that's the gateway, but the point is all of these were sending traffic and we were able to collect it. If we were to let this go a little bit longer, we would have gotten all the devices on the network. I think I have about 30. So we were able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So about half in about 30 seconds. So, pretty interesting. And definitely something that's great for troubleshooting any network. And you can also use it as a packet capturing tool. The SSD that I used was about a terabyte. So, you could use that and then just take the SSD, offload the packets, or you could just set it, to write a simple script to offload to your desktop machine, however you wanted to do it. But tons of different applications you can use this for. And, I think it's super useful to have, in your home network, some way to understand what your traffic looks like. So anyway, guys, hope you found this helpful. If you have any questions, please drop them in the comment below. And anything that I used or talked about in this video, I will link in the video description. So thank you guys, and I'll see you again in the next one. Bye-bye. All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear, or if there's anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.